Hey everybody, Mr. D here once again. Today in this video we're going to be looking to solve equations that have more than one variable, different types of variables located. So instead of just an x, we might have an x and a y, and how we're going to go about solving those. So in order to do so, let's take a look at this first example. You'll notice right away it looks a little bit different than any of the other problems we've done so far. So you look here, we're going to solve for star. And our equation here is smiley face plus star equals a flower. So take a second and jot that down. Those of you that are not artists, do the best you can to draw these symbols. Okay. And again, if we want to solve for the star, what you got to remember is we need to get this star all by itself. Right? The rules haven't changed. What we do has not changed. We need to get the star all by itself. So we need to get this smiley face to the other side. So in order to do that, since it's a positive smiley face, smiley face here is positive, we'll subtract the smiley face from both sides. Right? So once we do that, on the left side, all we have remaining is our star, right? Because the smiley faces cancel out. On the right-hand side of the equation, we would end up with flower minus smiley face. These are not like terms, so we can't do anything with them. We can't combine them at all. We would just leave it as that. Okay, and so in fact, our final answer would just be, if it says solve for star, well, star equals flower minus smiley face. There's no way to go any further with this because they're not like terms. One of the things you'll find in doing these types of problems, boys and girls, is that sometimes in a way they're actually easier because there's less math to actually do in some cases. You're just moving the terms around, and sometimes there's less computation to actually be done. Okay, so just remember, just think of them as symbols in a way. All right, nothing's changing about how we move these things from side to side. So let's take a look at the next example. All right, so here they want us to find the value of x for each value of m. So in order to do that, I guess the first thing we really have to think about is solve for x. All right, solve for x. All right, so if we get x alone, then what we'll do is we'll plug in these values of m, and we'll figure out some different values of x. Okay, so again, if we want to get x all by itself, the first thing we have to do is we've got to get this m term to the other side of the equation. So it's plus m. So let's subtract m. And what we do to one side, we must do to the other. So on the left side, the only thing remaining is our 4x. Okay. On the right side, we've got 12 minus m. There's really nothing else we can do with that. Right? We can't combine 12 and m. They're not like terms. So we just leave it as 12 minus m. Now, we almost got this x all by itself. We have 4 times x. So let's do some division there to free up the x from the 4. We'll divide both sides by 4. Okay, on the left side, we have x equals, and we have 12 minus m over 4. And there's nothing else we can really do to this. We could split this up into two fractions. It would make it 12 over 4 minus m over 4. For those of you who see that, we can certainly do that. But there's really no reason to do that. It doesn't necessarily simplify it any more than we have right now. This answer right here, this would be perfectly fine to have as our answer. Okay. So we can just say, if the question was, hey, solve for x, there's your answer right there. X equals 12 minus m over 4. And that's where we leave it as. I know it's a little bit strange, a little bit different than what we've been doing. Like I said, really no actual computation to do in this problem. We didn't add or subtract, multiply any real numbers. We just moved the terms around according to our algebraic principles. Here's where some math will come in. In this case, they're asking us here to solve when m equals these numbers. So we actually have 3 problems to calculate for here. We would just plug in for m. So we could have 12 equals 12 minus 4 in this case, over 4. This should be x equals. Alright, so I just replaced 4 with m for 4. 12 minus 4 is 8. 8 over 4, I think we know that that's going to be 2. Alright, so x equals 2 when m equals 4. Alright, we could do another one here, 8. So we plug it right in, x equals, I was doing so good with my equal signs there. I'll go back and fix that in just a second. 12 minus 8 over 4. You guys can work that one out in your head right now while I fix up my equal sign. 12 minus 8 is 4, 4 over 4. Right, and x should equal, you guys should all see this. Oh man, look, I jinxed myself. Alright, x equals 1. Okay, so x equals 1 in that case. Let's take a look at our third situation here, when m equals negative 8. Let's see if I can maybe trick a few on this one. Alright, 12. Now be careful when you plug in here. We have to take this minus sign right here, and we're plugging in negative 8 as well. Okay, minus minus, minus a negative, so that's going to be rewritten as x equals 12 plus 8. You can also think of it as negative times a negative. What's a negative times a negative? You guys all know negative times a negative gives us a positive. Okay, 12 plus 8 is 20. 20 over 4 . Well, that's just going to equal 5. Okay, so that's the way you would do it. Again, the keys here that we're looking at is how to solve for a variable, and there's other variables in there. Again, just like we did here with the m, and just move that m over like as if it was a number. You know, if this said 4x plus 2, you would subtract 2 from both sides. Just do the same principles, but just remember your ideas and concepts of like terms. So once I bring this number over here, this letter m, I can't do anything between the 12 and the m. If it was minus 2, then of course you know I would do 12 minus 2. But I can't do it. So just keep in mind your concepts of like terms, but move things the way you normally do. So hopefully this was very helpful to you guys, and I'll see you in class. Peace.